right, thank you guys for all coming out, whether you're here in person or joining us via the internet. We got another session, our second last one for this year. We're going to be starting off with our news roundup, and then we're going to have content team give us some rundowns on some common vulnerabilities. And then after a short break, we'll be joined by Alicia from Mandiant. She'll be joining us via Discord. But before we get started, as you know, our CTF registration is open. Keep on finding those teams, keep on signing yourselves up. You will have to join a team, even if you are planning to participate by yourself. You'll just have to make a team for yourself, so heads up. And as part of the preparation, getting you guys ready for CTFs, next week, Thursday, I believe that's December 1st, somebody can check that for me. We're teaming up with Fleming College. In their Discord, we'll be hosting Pico Night. So ISSessions and Fleming CSI, we're going to be going over some different challenges that you could see in a CTF through a wide variety of categories. Basically just giving you, the types of skills, not just, specific technical skills like how to do a SQL injection or something, but also just getting that correct mindset. When you get a challenge, what are you looking for? What are you reading? What kind of tools are you reaching for first? So if you plan on joining the CTF, which is an event I highly recommend, then I highly recommend this event next week. So Pico Night, 8 p.m., Fleming's Discord. I'll be posting a follow-up announcement. Aside from that, we're ready to take it with the news. Nero, you can start us off.
Hey everyone, so our first article for the session, researchers at Phylum and Checkpoint reported seeing malicious packages on PyPI, the open source package repository for Python developers, through a social engineering technique called typo squatting, which is when malicious packages are given legitimate sounding names or names similar to real packages. Developers are tricked into downloading and installing malicious packages. Another technique that these attackers used is called starjacking, which is stealing GitHub stars from a legitimate package to make the malicious one look more popular. In this case, the malicious Python packages contain malware called WASP, which steals users' information such as Discord accounts, passwords, crypto wallets, credit cards, and any other interesting files on their machine. This information is sent back to the attacker through a hard-coded Discord webhook address. WASP uses a few techniques to avoid detection, and these are steganography. So once the malicious package is loaded, it's set up scripts, install additional Python packages, and downloads a .png image and saves it to the operating system's temporary folder. This image contains more hidden code that can be extracted. It also uses polymorphism. And currently, WASP is being sold to other cyber criminals for $20. Payment comes in as cryptocurrency or gift cards. Whenever these malicious packages are found on PyPI, they're deleted by Python's security team. However, the unknown attacker creates a new identity and uploads the packages again. And for now, the attack is ongoing. So Article 2 is about Meta platforms. Meta reportedly has fired dozens of employees for, the tech conglomerate Meta Platforms is said to have fired or disciplined over 24 employees and contractors for allegedly using their access privileges to compromise or take over Facebook and Instagram accounts, and in some cases in exchange for bribes. An internal investigation has shown that these accounts were accessed using an internal tool available to certain employees called OOPS, short for online operations. The investigation uncovered a black market of sorts that links users and insider Meta employers. In the event that a user forgets their password or gets their account blocked, users could pay thousands of dollars to have an intermediary reach out to an insider willing to reset their account. And one case involved a contractor that was fired after she reset multiple user accounts on behalf of hackers in return for Bitcoin. In another case, a contractor claimed that he was tricked into assisting unnamed third parties to get unauthorized access to Instagram accounts by filing fraudulent OOPS reports. The number of accounts recovered or reset in 2020 is estimated to be at around 50,270, which is more than double the amount in 2017. and Meta has stated that buying or selling accounts or paying for account recovery is a violation of its terms of service.
All right, so due to some car troubles, Jackson with a Y, he's having to join us through Discord. But nonetheless, the show will always go on. Jackson, you want to unmute yourself and let's just see how our volume's sounding?
Hey, Jack, can you hear me?
Yeah, you're coming in good, I'd say. Take it away.
All right, no problem. Hey, everyone. Unfortunately, I can't make it, but like Jack said, the show's gotta go on. So, in today's talk, I'll be discussing topics regarding a ransomware criminal gang by the name of Hive. Hive has successfully hit more than 1,300 companies globally, extorting about $100 million from its victims over the last 18 months, according to the FBI. The FBI has been alerted of their presence since June of 2021 and has gained notorious traction when they attack a multitude of hospitals. The U.S. Health and Human Services, HHS for short, agency warned healthcare organizations about Hive, in which HHS described them as an exceptionally aggressive threat to the health sector. The gang also targets government facilities, communications, critical manufacturing, and IT. The technique Hive used was a critical authentication bypass bug to break into networks, and then after, they would identify processes related to backups and antivirus tools in which they will disable and evade detection. Afterwards, they would steal and encrypt the data and then drop a ransom note called howtodecrypt.txt into each compromised directory with a link to discuss payment and a deadline to pay up. Next slide, please. For the second news article, this is also related to ransomware. However, it deviates from the previous article such that it uses Google's ad system to distribute post-compromised payloads. Microsoft started to take note as this new method called Royal ransomware was on the rise in late October of this year, and according to a Microsoft spokesperson, observed dev-0569, this is the name of the group responsible for this attack, shows a pattern of continuous innovation with regular incorporation of new discovery techniques, defensive invasion, and a variety of post-compromised payloads, alongside increasing ransomware facilitation. The group dev-0569 is known to rely on malwareizing to point unsuspecting victims to malware downloader links that pose as software installers for legitimate apps like Adobe Flash Player, AnyDesk, LogMeIn, Microsoft Teams, and Zoom. The hackers took advantage of a search engine optimization, SEO for short, poisoning to lure users to download the malware from compromised websites or attacker-created domains. Microsoft's Security Threat Intelligence team further comments that DEV-0569 has used a variety of infected chains using PowerShell and batch scripts to evade detection. And that's it for me.
Here. All right, thank you. Thank you again, Jackson. And thank you, Narrow, of course, for delivering the news for us. Kind of the futuristic news using the internet. So we're going to be getting into our middle segment here. And maybe also kind of relevant for our CTF. This one's going to be covering some very common vulnerabilities you might see, in the wild, in the workplace, or maybe in a CTF. Maybe one coming up in January that's hosted downtown and also online. And is maybe also super beginner friendly.
Yeah.
Maybe something you can put on a resume, but that's enough shilling the CTF for today at least.
Yeah.
Jackson with a G, do you want to take it away?
Yeah. Okay. So for our segment today, we're going to be talking about vulnerabilities. So we're going to kind of do this in a bit of a three-step process. So we're going to kind of explain what the vulnerability is and how it works. We're going to show a quick demo on kind of how to do it. It's either in pictures or like a online CTF challenge. And then we're going to kind of show how to protect against this vulnerability and how to mitigate it. So just a quick show of what we're going to be talking about. So first, we're going to talk about SQL injection, then cross-site scripting, then directory traversal, and then buffer overflow. So we're going to start off with Thing on SQL injection.
Hey everybody. So I'm starting with SQL injection. Some of you are already familiar with it, but it has to do with the SQL databases. So it's essentially an attack in which malicious code is inserted into strings that are later passed as an SQL server query, and then it parses it and executes it within the database. It's usually done with web input fields, things like usernames and passwords. It could potentially destroy your database with the right code, or should I say the wrong code. And it's one of the most common web hacking techniques that are out there being used. So how does it work? As I mentioned, it asks users for an input, username, user ID, passwords, but it ends up being manipulated as an SQL statement, and then it gets run on your database. So there are two types of them. There's the direct method, where it's inserted as a user input directly from a user, and then run as a command and executed. And then the indirect type is where the strings are edited, stored in a database table, and then concatenated, and then later executed as well. An injection typically terminates the text string and then appends it as a new command. So here we see that a variable is created, and based on the user's input, it essentially replaces the user ID parameter. And in this way, attackers can basically manipulate what's being put into the string. The first method we see here is based on the idea that 1 equals 1 is always true, as we all know. And here in the, so here in the user ID field, we see the user is entered as 105, or 1 equals 1, which would return true. The field would be translated into an SQL query, and we see here that it says 105 or 1 equals 1, and eventually it returns the user table, all of the rows of the user table, which could potentially include the username and password of the user. An alternative attack is based on the equal sign is always true, where the username and password are both given, and the parameters are also passed to the query, but this time it's translated from the variables given by the user. But this is just a continuation of that, where it translates, the username from the database, and the password is basically given. So they're very similar methods in achieving the same result. This is just a continuation of the previous information here, but we do see that the equal sign and or are passed into the query. Okay, so another method here is based on batched SQL statements. So you can essentially add more than one sort of argument that will get passed into the database and do, multiplied damage in the database. And then one method of prevention is pretty much using a controlled manner. Here we see the @ marker in the argument, and it basically translates the argument parameters where the column is treated literally and not as part of the SQL. And so the servers will always execute valid queries it receives unless otherwise told. And one of the best ways to avoid any kind of attack like this would be reviewing the procedures that construct SQL statements. And now Jackson is going to come down and give you guys a demo.
Okay. So just escape. Oh, yeah, I always forget. Okay, so for our demo today, we're going to be using a challenge from Pico CCF. It's from the 2022 CTF, so you guys can actually go on and get 300 free points if you want to. I mean, it's a pretty easy challenge. 94% of or 98% of the people who tried it succeeded, so I'm sure if you try it, you won't have that much trouble. So basically, the idea is we're trying to log into this website. So something that's kind of useful that we can look at is if we press login, it'll bring us to this page. So it'll either say login failed or login succeeded and then give us a flag. So it shows us the username we put in and the password and then the SQL query that is run. So we can then kind of see how we can mess with this a little bit and make it do whatever we want. So I keep moving it to the other. So we're just gonna go back quick and we'll try, okay, Jackson and 1, 2, 3. Okay, so login failed. That's not the right password. So yeah, so select everything from users where name equals Jackson and password equals 1, 2, 3. So obviously that doesn't work. So what we're going to try to do is we're going to do the method that Singh talked about where the or 1 equals 1. It's pretty simple. Basically, we are going to take this part, the last part with the and password, and we're going to comment that out. So basically, it's going to let you log in and just basically say, instead of checking a password, it'll check if 1 equals 1 and 1 equals 1. So it'll work. So there are a few ways. I played around with this a bit. Also, just to make this easier, from the hint, admin is the user we want to log in as. So that might make it a little easier in some ways. So I'm going to show this a few different ways just for like completion's sake. And so the first way I'm going to show is you don't actually need to put the username or the password in. Or, no, you need to put the username but not the password. So you don't need to put anything in the password is what I mean. So we're going to put admin. I'm going to put 1 bracket. That'll close it. And then we're going to do or 1 equals 1. And so here we see it doesn't work. And so that's because of the stuff at the end. So the brackets give it an error. The commas, the colons, I mean, give it an error, and then it doesn't close, so it doesn't work properly. So what we're going to do is we're going to do the comment character. I'm sure with coding and everything, you guys have done comments before. So we're basically going to do the same thing there, but we're going to put a comment at the end of our thing, so it'll comment the rest of the line. So based on the challenge name, we can see that this uses SQLite, which has 2 ways to comment. So the first one is you do dash dash, and then so I'm gonna click login. And so yeah, ooh, we logged in. And so yeah, it's just asking you to check the source code for the page, and the flag will be right there. But I'm just gonna show a few different ways just for interest. So the other way you can do a comment, I believe it is slash and asterisk. So that also works. Ooh. So basically it's saying that we don't need to that this and password equals is just a comment. It doesn't do anything. It's not a command at all. So we're basically just saying select from users where name equals admin or 1 equals 1, which 1 does equal 1. So it'll let you log in. So the other way we can do this is basically we can do the same thing Oh, we having trouble?
Go back to Discord.
Oh, don't know how that happened.
It disconnected for some reason.
Okay, we're back. I think we should be.
Yeah, I think we're good.
Okay. I'm sure they'll tell us in Discord if we're not. So another way is we can just do this kind of in the password, and it'll pretty much do the same thing, just in kind of a different spot. So, yeah, look. Ooh. I'm not going to save this for Jack's Google. I don't know if his Gmail would appreciate him putting in a SQL injection login. Imagine that. If they'd be like, what are you trying to do? I'm sure they have things against it, though. And those are basically the two ways I found it. And yeah, so like I said, this is a public challenge. You can try it out if you want, or try some harder ones out. There's a lot of different things, just we don't really have time to go into it today. And it's a little complicated, so yeah. So, slideshow. And next will be Tommy with cross-type scripting.
Hey everyone. So yeah, I'm going to be going over cross-site scripting, or abbreviated as ISSessions. So cross-site scripting, it's a type of injection where malicious scripts or code are injected into a website. And these attacks often occur anywhere where a web application takes user input and doesn't validate or encode the input before using it. An attacker can use cross-site scripting to send a malicious script to an end user, and the user's browser will execute the script since it believes it came from a trusted source. Since the browser thinks the script is coming from a trusted source, the script often has access to any cookies, session tokens, or other sensitive information retained by the browser and used with that site. So we're going to be going over the three different types of cross-site scripting. So there's reflected, stored, and DOM. So the first one, reflected, it occurs when an attacker injects browser executable code within a single HTTP response. The injected attack is not stored within the application itself and can only impact users who open maliciously crafted links. The attack string is included as part of the crafted URL, which is improperly processed by the application and returned to the victim. When a web application is vulnerable to this type of attack, it will pass unvalidated input sent through requests back to the client. So here's a very basic example of reflected cross-site scripting. As you can see highlighted up in the URL, they put a script in there that opens up an alert box containing 1, 2, 3. So that's very harmless, but as you can probably imagine, it can you can do a lot more malicious things. Yeah. And then our next type is stored cross-site scripting. So this type is considered to be the most dangerous type, and it occurs when a web application gathers input from a user, which might be malicious, and then stores that input in a data store for later use. The input that is stored is not correctly filtered, and as a consequence, the malicious data will appear to be part of the website and run within the user's browser under the privileges of the web application. And then we have our example of that one here. So once again, the script is put into the URL, but this actually shows the stored values of the session cookies. So I also wrote the script down here in the actual slide. And yeah, and this specific script will send the cookie information to the attacker's specified website, which is the IP address in the script there. And with this cookie information, an attacker can hijack a user session without their knowledge. And then for our last type of cross-site scripting, DOM-based cross-site scripting, it's a result of active browser-side content on a page, typically JavaScript, obtaining user input and then doing something unsafe with it, leading to the execution of injected code. So the DOM, which is the document object model, is the structural format used to represent documents in a browser. The DOM enables dynamic scripts, such as JavaScript, to reference components of the document, such as a form field or a session cookie. The DOM is also used by the browser for security, for example, to limit scripts on different domains from obtaining session cookies for other domains. A DOM-based cross-site scripting vulnerability may occur when active content, such as a JavaScript function, is modified by a specially crafted request, such as the DOM element that can be controlled by an attacker. I don't have a screenshot for this one, but the example here, it's very similar to the first one, where it's a constructed URL. But the main difference between this one and the other types is that this will create a DOM object for the page, where document.location will contain the JavaScript code in the URL, the script that the attacker would put in there. And the original JavaScript code in the page does not expect the default parameter to contain HTML markup, and as such it simply decodes and echoes it into the page, into the DOM at runtime. The browser then renders the resulting page and executes the attacker script. So the main difference here is with this type of cross-site scripting is the HTTP response sent from a server does not contain the attacker's payload. The payload manifests itself with the client-side script at runtime when a flawed script accesses the DOM variable document.location and assumes it is not malicious. So I just have a few points here on how to prevent it. So I mentioned at the beginning, the most common way to prevent these things is to validate the input or encode the user input. And then specifically for the second example, is you can set cookie attributes in JavaScript, so the HTTP only cookie. You initialize the cookie value through the set cookie header. And then the last one for the DOM, it's what I talked about here, the DOM.location. Just make sure that it's encoded and it'll reduce the impact or possibility of any DOM cross-site scripting attacks. And that's it for cross-site scripting.
Did I see right the screenshot? You used the invulnerable web app.
Yeah.
You just want to mention what that is real quick because it's a pretty cool resource.
Yeah, so I mean, you guys can look up the damn vulnerable web app. It's basically a website that you can run locally, and it has a bunch of vulnerabilities where you can practice on in a safe environment. Yeah, I mean, you guys can look it up and look into it. It is a great tool, absolutely. So yeah, once again, that's a damn vulnerable web app.
I think we actually have a talk on it, which I can link in chat, which you might be interested in looking at after this session. But anyways, I think your next session.
Yeah.
Future versus directories on that.
So directory traversals or path traversal is an HTTP exploit. It takes advantage of a security flaw in a web server to access stored data, to access restricted directories, run commands on outside of the root directory of the server. When a user can see or download a file from application via URL, a parameter. After successful directory traversal, attackers may also be able to read arbitrary files of the server that is running on application. This may compromise sensitive operating system files, application code and data, and backend systems login information. In some circumstances, an attacker may also be able to write arbitrary server files, which may give them the ability to change application data or behavior of ultimately seize total control of the server. A directory traversal attack typically takes advantage of web browsers that implies that every service that accepts unverified input data from web browsers is open to attack. Threat actors frequently search through a directory tree to find routes to prohibit files on web servers before launching this assault. A demonstration is, I couldn't find a nice neat one, so I just sort of wrote it in a big text. So a simplest way for directory traversal is an attack or an application displays that allows the user to download a file via a URL parameter. For instance, if a user enters a file name image1 PDF and the website uses the following URL to download the PDF to the user's computer, you see that's the URL below it. If the application does not filter inputs, it will then utilize the attacker string in a system call, change the root user, and then give the attacker access to the execution directory. Then the attacker is able to access the password file and may seize control of the whole server. The string slash dot dot can be used on Windows systems, while dot dot slash is used for Linux mostly. And some few preventions is developers should check any user input that browsers accept. Input validation can help ensure that attackers are restricted from the use of command techniques like SQL injections, which violates access to privileges and may provide attackers access to root directories. Application filters should be used to prevent questionable user inputs. Most web applications use filters to reject URLs that contain instructions and frequently used attackers' escape codes. And lastly, regular software patches and security patches can drastically lower security risk and the potential for exploitation, and of course for directory traversal. And next up is buffer overflow.
Hey, thanks, Patrick. So I'll try to keep the text to a minimum here. Hopefully you all can see like a little red dot here to help with the explanation, because there's going to be a lot of pictures. So a buffer overflow. So when a program writes data to a buffer you can think of as like a temporary space allocated to like memory. And the overflow part is when the buffer is exceeded, or if it exceeds the bounds of the buffer, it causes excess data to overflow into adjacent memory. Okay, so a buffer, as I mentioned, is just a sequential section of memory that contains anything from a character string to an array of integers. So if more data is put into a fixed length buffer than the buffer can handle, the data overflows into adjacent memory space, corrupting or overwriting in that space. So this can result in a system crash, as well as an opportunity for an attacker to execute arbitrary code, which is just meaning that the attacker could take advantage of this and insert their own code. So there's three types of buffer overflows that I've listed here. There's more, but I think these three are okay for now. So stack-based overflow attack, which is the most common type of buffer overflow attack. It involves a buffer overflow in the call stack. We'll talk about that later. There's a heap overflow. This type of attack targets data in the open memory pool known as the heap. And the integer overflow attack, when an integer overflows and an arithmetic operation results in an integer that is too large to store for the integer type, and this results in an integer overflow. So the other two are kind of out of scope for like my part of the segment. We're mainly going to be focused on the stack overflow attack since it's the most common. Okay. As you'll know from C, just remember that that even when a string has a declared length, you terminate the string with an old byte, and that counts as a byte. Okay. One of the more vulnerable functions that you find in C is actually called getS. It's been deprecated from C because of how vulnerable it is. The reason why is because, we'll just look at this. It says, reads line from a standard input from the user into a buffer pointed to by us until either a terminating new line or end of file. You don't specify a buffer boundary here. So what happens is that if you put in user input, it'll just keep going until reaches a new line, but that won't be the case. Similar to scanf, where scanf actually terminates on white space. So we can say it's just as vulnerable as getS. So just keep this in mind for now as we do like the little explanation afterwards. Okay. Just as I mentioned before, receives input from a keyboard until it encounters a new line or end of file. Does not perform boundary checking, meaning it is vulnerable to a buffer overflow attacks. So deprecate on modern versions of C. You don't use this in code nowadays. Okay, so here's a little piece of code that has been written. We have char name that has been allocated 64 bytes, 63 if you count the null bit at the end to be 64, and printf, what is your name? So getS prompts the user for an input, and let's see what happens. You can probably already see what's going to happen here. Okay, I've put in more than what was allowed in the character array, so more than 64. And what that did is that it caused a segmentation fault. So You can think of a segmentation fault as sort of like a system crash at the point your code just stops. But what's happening is that your processor it's trying to tell you that a part of memory was accessed, and it had tried to be written into when it was only read-only. And what could happen in that case? It just, again, behaves unexpectedly and crashes. Okay, now, how does this logic apply to cybersecurity in particular? It applies in a sense that you can see already that you can take advantage of how functions call each other. You'll see this in the next slide. So let's take it up a notch, and let's take a look at two functions here. So of course we have main, x and y. We have integer z, which calls the function add, returning a and b, and just ends with printf, of course printing integer z. Okay, same thing here. Now, let's take a look at the stack. So the stack here is essentially visually what's going on in memory. So how exactly is this function call here? How is this program running in memory? What's the order, what's going on, and where is everything happening? Okay. The arguments from main get pushed to the top of the stack. So here, main locals, then y, then x, because when we're doing a stack structure, it gets put into reverse order. So when you pop it, it pops x first, then y, but it's placed in reverse order. After this, the processor needs to remember where in main to go to after add returns. So this is known as the return address. You can see over here, okay? And that's also pushed to the top of the stack. So again, where in main to return to. Add gets executed and makes room for its own local variables, okay? And lastly, the program returns to main where the function got called. So you can already see the problem here, hopefully. Remember that when I talked about getS, that when you exceed a specified length, it spills over to other areas of memory. What happens if add were to take in a user input of, let's say, like a short buffer, okay? But then it exceeds the boundaries. It'll spill over to return address and then cause a segmentation fault. Okay. Now let's take this up another level, okay? Now we have main, we have check password, and we have debug. So the point of this, this program here is, let's say that you want to have access to a server. What the program will do here is that it'll prompt the user for a password using getS, as we've mentioned before. It'll check the password, and if you succeed, then you'll have access to, system shell, okay? Here, main checks the password, and you can't see it here in code, is valid password, but it checks the password to see if it's correct. Again, the password is checked using getS. And password takes a length of 63 plus the null byte. Okay? But if we overflow the password buffer of 64, then you could exploit it in a way that you can overwrite the return address. You can overwrite the return address and instead move directly to the debug function without knowing the correct password. But that assumes that, keep this in mind, that assumes that we know the address for debug in memory. We would need the address for debug for this to work. Okay. And this is what it'll look like visually on the stack. So we've input enough variables or characters, and we've overwritten into the return address. So it'll go straight to debug, bypassing valid password, and then we'll have access to a system shell. Okay, but let's consider this. I'm keeping it simple for now. I'm not keeping it complicated for a reason. So just because we have written more than the buffer size doesn't mean that you've done the exploit correctly. Okay, you have to consider the length of the buffer, as I've mentioned, as well as the processor registers when trying to exploit a buffer overflow vulnerability. So in this case, we're talking about the stack pointer, the base pointer, and the instruction pointers, as well as what sort of payload that you want to use. For the return address, we're using debug because we know the memory layout and we know what the code looks like. The ultimate goal here is we're writing the return address on the stack, so when the called function returns it, it loads the address that we want. So this is just another visual representation of what's going on. You want to determine the offset. So you want to have like a specific amount of, let's say, characters to use when writing into your buffer, over your base pointer, and over your return address. Okay. Usually when you produce a segmentation fault, that gives you a good indication that you've overwritten your return address, and that gives you a good indication that you could calculate your offset and replace the return address with one of your own. Okay, as I'm explained here, and that. But again, that assumes that you know the address for debug, which you can find using tools like GDB, Jeff, and then you would craft a payload using Pwn tools, and then in this case you could essentially pull this off. Okay, now let's talk about some prevention. There's OS runtime protection. There's more than one, but I just chose to talk about one today. Address space layout randomization, which randomly arranges the address space positions of key data areas in the process. So it doesn't rearrange your code. It rearranges like the memory calls like internally. Device patching, using safer function alternatives. So fgetS as opposed to getS. fgetS is used because there's a parameter that allows you to perform boundary checking, which means stating the how big you'll allow your buffer to be, as well as data input validation. So this one should be common. You do this across like all of these sort of vulnerabilities because you want to make sure that the input that you're receiving from the user is like for its intended purpose. When we're talking about real-world examples of a buffer overflow, one I can think of is actually Eternal Blue, which exploits a vulnerability in SMB v1 protocol. There's like 3 bugs in Eternal Blue. One of them has to do with a buffer overflow. The second has to do with heap spraying, and the third one I forget. But that sort of vulnerability was used to propagate WannaCry, which is like a huge ransomware attack that happened like 5 years ago. But yeah, that's my part. Okay, thank you.